Hi, so here we have a C code where I have declared a character variable x as 2, and here I'm doing a multiplication by 8 and then adding with 1. Alright, so 2 times 8 will be 16 plus 1 will give me 17. Alright, so if we run this, we see the answer as 17. Alright, now this is of course perfectly fine. Alright, but it is a very inefficient operation, especially when it comes to translating this into actual assembly. Alright, because when we leave it to the compiler, alright, we do not know exactly, we can't say for sure exactly how this will get compiled, okay, when it comes to assembly language. Alright, and if it makes use of the multiplier block, okay, in the processor, okay, then this operation x times 8 will take many clock cycles, okay, which is highly inefficient, right? So what we can do, all right, is to make use of another hardware block within the processor, okay, which all processors have, which is the shifter. All right, the shifting block within the processor. And basically we know, all right, that when we shift left, okay, every time we shift left we multiply by 2, shift right we divide by 2. All right, and basically the rule is every time I shift the number of bits, it is multiplying 2 to the power of n, where n is the number of bits. All right, so 2 to the power of 3 is 8, so multiplying by 8 is equivalent to shifting left by 3. Okay, so when I shift left by 1, I multiply by 2, so and when I shift left one more time, it will multiply by 4, and one more time it will be 8. Okay, so it is 2 to the power of 3. Okay, so if I make this small change to the code and I run it, okay, I'll get the same answer. But in terms of executing this on a hardware platform or on an embedded platform, this is far more efficient than uh, multiplying it by 8. All right, because by doing it this way, we are ensuring that the compiler will use the shift operation in assembly language, which translate to the actual shifting hardware that we have in the processor. All right, so this is one way in which you can improve the efficiency of your C code. All right, thank you for watching. I'll see you in my next video. Thank you.